In this video, we're learning how to convert scientific notation to standard form. And scientific notation is just a useful way to write really big numbers or really small numbers so that we don't have to write out all the digits. So if we look at the top of our screen, we're going to see some tips that say positive exponent means move to the right and negative exponent means move to the left. And that'll make more sense once we start doing some problems. So let's take a look at example 1. So in example 1, we have the number 3.7 times 10 to the third. And this number is written in scientific notation, and the way you can tell is that this first number is between 1 and 10, so it's greater than or equal to 1 and less than 10. And this number right here is 10 raised to some power. So that power can be positive or negative. In this case, we have a positive exponent. So now I'm going to show you guys how we can write this in standard form, which is just the way you normally see numbers. So at the top of our screen, it says that positive exponents mean move to the right. So if we look at number 1, we have a positive 3 exponent. So what that's going to tell us is that we want to move our decimal point 3 places to the right. So what I'm going to do is I'm going to take 3.7, and I want to take my decimal point and move it 3 places to the right. So I'm going to go 1, 2, 3. So it's going to end up here. And I need to fill in these spaces with zeros. And then just to write my answer a little bit more neatly, I get 3,700 as my answer. So 3.7 times 10 to the third, written in standard form, is 3,700. Let's try another one. If we're looking at example 2, we have 9 times 10 to the sixth. So again, we have a positive exponent, so this is going to tell us to move to the right. And this time it's a positive 6. So we want to go 6 places to the right. Now, our first number, 9, doesn't have a decimal point. So we just want to put a decimal point right to the right of it. So 9 is the same as 9.0. So I'm just going to write it like that. And now I want to take my decimal point and move it 6 places to the right. So I'm going to go 1, 2, 3, 4, 5, 6. I'm going to fill in the blank spots with the zeros. And now I just want to write my answer a little bit more neatly. So I get that 9 times 10 to the sixth is the same as 9 million written in standard form. So now let's take a look at 2 examples that have negative exponents. So in example 3, we have 4.68 times 10 to the negative fourth. So if we look at the top of our screen, it says negative exponent means a move to the left. So we have a negative 4 exponent, which means we want to go 4 places to the left. So we want to move our decimal point 4 places to the left. So I'm going to start by writing 4.68. And now I want to take my decimal point and move it 4 places to the left. So 1, 2, 3, 4. It's going to end up here. I will fill in these spaces with zeros. So we get 0.000468 as our number written in standard form. So what's important to notice is that if you have a positive exponent, when you write it in standard form, you're going to get a big number. But if you have a negative exponent in scientific notation, you're going to get a very small number, something less than 1, greater than 0, when you write it in scientific notation. So taking a look at example 4, we have 2 times 10 to the negative fifth. So again, we have a negative exponent, so that's going to tell us to go to the left. So we need to go 5 places to the left this time because we have a negative 5. So I'm going to start by writing 2 as 2.0 since it doesn't have a decimal point. And now I want to go 5 places to the left. So I'm going to go 1, 2, 3, 4, 5. My decimal point ends up here. I fill in the blank spots with zeros. So this is equal to 0.00002. So that's how you write 2 times 10 to the negative fifth in standard form. Let's go through 4 more examples just to make sure that we've really got this down. So for these last 4 examples, I encourage you guys to pause the video and try them on your own, and then you can watch me work through them to make sure that you've done them correctly. So example 5 is 6.35 times 10 to the fifth. So we have a positive exponent. So this tells us we're going to the right, and it's a positive 5, so we're moving 5 places to the right. So I'm going to start by rewriting 6.35. And now I'm going to move the decimal point 5 places to the right. I go 1, 2, 3, 4, 5. My decimal point ends up here. I fill in these missing spots with zeros, and I can rewrite this as 635,000. Taking a look at example 6, I have 7 times 10 to the 8th. So again, I have a positive exponent, so I'm going to the right, and this time I'm moving my decimal point 8 places to the right. Because 7 doesn't have a decimal point, I'm going to rewrite it as 7.0. And now I'm going to move the decimal point 8 places to the right. So we go 1, 2, 3, 4, 5, 6, 7, 8. Ends up here. We have to fill in all of these zeros. And I'm just going to rewrite this so it's a little bit neater. Put my commas in and I get 700 million. Moving on to example 7, we have 9.513 times 10 to the negative second. So this time we have a negative exponent, so we're going to the left. So we want to move our decimal point to the left 2 times. So I'm going to start by writing 9.513 down here. And I want to move my decimal point 2 places to the left, so it ends up here. I fill in this space with a 0, so I get 0.09513. And finally, taking a look at our last example, we have 4 times 10 to the negative 6th. So again, we have a negative exponent, so we're moving to the left. This time we're moving 6 places to the left. I'm going to start by rewriting 4 down here as 4.0 since it doesn't have a decimal point. And now I want to move that 6 places to the left. So I'm going to go 1, 2, 3, 4, 5, 6. My decimal point ends up there. I fill in these spots with zeros. And I can rewrite this as 0.000004. So hopefully this video helped you guys learn how to convert numbers from scientific notation to standard form. You just have to remember that positive exponents mean move the decimal point to the right, and negative exponents mean move the decimal point to the left.